to Gibbs Academy. This lesson we are going to talk about the Mason gain formula. Here I'm going to state the formula, explain the formula, what it's all about, and lastly, that will be stage number 3, is to apply the formula to solve some problems, to come up with the transfer functions of a given signal flow graph. So as we discussed the other time, we said the Mason gain was is a formula that was discovered by the Masons, and it's very useful, very helpful in coming up with the overall gain of any signal flow graph. So the overall transfer functions based on this Mason gain formula states you can have ds to stand for the overall transfer functions, which is equals to 1 all over the delta, the sigma, the gain of the forward path k, and theta k. So here we want to see what is all about these terms. So k gives us the number of the forward path. B is the gain of the forward path, the gain of the forward path. Delta k is given by 1 minus the loop gain. The loop gains not touching the forward path. Delta, the overall delta, is given by 1 minus the individual loop gains, the product, that is the product of the individual loop gains plus sum of 2 non-touching loops minus sum of 3 non-touching loops plus etc. It goes on like that. So that is the definitions of these terms. So K stands for the number of the forward paths. I'll show you that. P is the gain of the forward path. Delta K is given by the loop gain not touching the forward path. And delta, that is the overall delta, is given by 1 minus individual loop gains plus the sum of two non-touching loops, and then you go to that one minus the sum of 3 non-touching loops. So this one will give us the overall. This one will just only give us the loop gain of only the part of the forward path which is not touching. To given that test again will give us that, and then P will give us the forward path of the gains, and then K is the number of the forward path. So for example, if we to take K to be 2, that means there are 2 forward bar. And what will be the formula? So the transfer functions will be B1 delta 1 plus B2 delta 2 all over the overall delta. So if we have two forward bars, then the formula will yield to this. Now if K is equals to 3, then the formula will yield to P1 delta 1 plus P2 delta 2 plus B3 delta 3 all over the overall transfer, the overall delta. So the formula will only vary based on the number of the forward bars which you've been given, but the formula remains to be this. The formula remains to be that. So we want to see an example. Want to do an example. So we can maybe try to attempt one example, then we just draw one, and then we see how we can come up with the overall transfer function input and the output. It runs from the input all the way to the output, like as we can see from here, RC, which means this is a forward bar, this is going like that out to that C. So we can have this to be the first forward bar, and then also we have also this one going up, and then finally going to C. So based on our signal flow graph which we have been given, we've got two forward bars. So we've got two forward bars. So it is this one, which is number one. Number two is this one. So we've got two forward parts. Then also we are also supposed to be able to come up with the or to tell the loops. So the loops, like for example, we have this. This is the it forward bar, and then this one is the feedback. So it has the forward, and then it has the feedback. So these ones form a loop. We have also this one. This one happens to be the forward bar, and then this one is the feedback. So forward, feedback. So we've got this, and then it goes back. So it starts from here, and then it goes up to this point number 5, and then from point 25, and then it goes back to its reference point. That one forms another loop. So we've got two loops. So we can take this one to be loop 1, and then this one loop 2. So we've got two loops. We've got two loops. So from there, our formula seems. So our formula is this, but now based on this, since we've got two forward bar, then our formula will be, the transfer functions will be P1 delta 1 plus P2 delta 2 all over the overall delta. So this is going to be our formula. We write this formula based on that formula game as a result of the number of the forward parts. We've got two forward parts. So two forward bars. So one will be for this one, and then the other one is for this one. So if we take, for example, we have to label, we can take this one to be the first forward bar, which we are going to be B1, and then the other one, which we shall call it B2. And then now we apply delta 1, which we were saying delta 1 is given by delta 1, delta, in general we were saying delta K is equals to 1 minus loop gain not touching the forward band. So same case to this. So let's see step by step. So the first one, we are going to determine the gains, the forward band gains. So the first one, or before we look at that, there are things that we are supposed to know, the steps of coming up with a transfer function of any signal flow graph. So one, as we have seen, we determine the number of the loops. Secondly, we are also supposed to determine the number of the loops. And then lastly are the substitutions. So one is you determine the number of the forward bands, number of the forward bands. Two, you are supposed also to determine the number of the loops. And then three is to determine the deltas. You determine the deltas. You determine the deltas. And then lastly, but not the least, number 4, you look at the sum of 2 non-touching loops. Then lastly is to do substitutions. You substitute based on the formula 1 all over delta summations of k pk, and then the product of delta k. So let's answer this question. So bear in your mind that whenever you are given any signal flow graph and then you are asked to determine the transfer functions, then first of all you consider how many forward bands, how many loops have you been given, and then also you determine the deltas. Then you also go to the sum of 2 non-touching loops. In most cases we are given to have to do, so you are also supposed to go after the 3 non-touching loops. And then from there, after you have done that, then you do the substitutions using the Mason gain formula. So let's answer that question. So one, ya kwanza is the gain of the forward part. That is number 1. So we are going to start with B1. B1 is going to be equals to, I've not given you the gains. You can give this one to be the gain to be G1, and then this one's to be G2, and then this one's going to be G3, and then this one G4. So if that is the case, then how do you determine this one? You're going to find the product of the gain along that forward part. So it is going to be G1, G2, G3, G4. So that one forms the gain of the first forward part. Then secondly, you go to number 2, the second one, which is this one. And the gain of that one is G5. can take the gain to be G5. The gain to be G5. So how will we determine it? We are going to follow it like this. We have the gain to be G5 and then G4. And then the gain here is 1, the gain here is 1. The product of that is going to be G5, G4. So we've completed the first part, the forward part of the signal flow graph. We've got 2 forward part. So number 2 is now to determine individual loop gains. So 2 to determine individual loop gains. So based on what we stated, we say based on that signal flow graph, there are only two loops. There are only 2 loops. So loop number 1, which we say L1, is going to be, the gain is G1 multiplied by the product of negative H1. So it's going to be H, G2, H1. L2, which is this one, is going to be G1. There is this negative, so it's going to be negative G1, G2, G2, G3, G4, and then H2. So we are through with individual loop gains. Now, number 3, step number 3 is to determine the sum of 2 non-touching loops. So, sum of 2 non-touching loops. So this ones, so we want to see the loops which are not touching each other. So how do we determine, how do we tell whether they are touching each other or they are not touching each other? You base on this one, L1, that is loop 1, and loop 2, see what is common. What is common? So I'm seeing here G2, and on the other side there is also G2. So that means those loops are meeting at G2, are touching at G2. So this one, this loop gate, this loop, and this one are touching at G2. So some of the 2 non-touching loops we don't have. So we say no. There is no non-touching loops, and for our case 2, we don't have 2 loops which are not touching. So L1 and L2, what is common is G2. That means the 2 loops are touching at G2. Make sure that you know that. So we don't have that. So secondly, then we go to the delta 1. Delta 1 is going to be 1 minus the loop gate not touching the forward part. So we were taking this one to be the first forward part. So we look for the loop gate not touching the forward part. So based on what we have been given, this one and the other loop are touching the forward part. That means we don't have. So the first D1 is going to be 1 minus, because we don't have, then we are going to say 0, which is going to be 1. delta 2, which is this one. So this one is touching the first forward part, but this loop is not touching that second forward part. So we are going to say 1 minus the loop gauge not touching the first forward part, so it is L1. L1, which is this, is going to be negative G2 H1. So the answer is going to be 1 plus G2 H1. Then lastly, the second class is to determine the loop, the total delta, the total or the overall delta. And our delta is going to be equals to, we were saying it is equals to 1 minus individual loop gains plus sum of 2 non-touching loops. And based on what we came up with here, we were saying there are no non-touching loops, so we don't have this. So it is going to be equals to, the delta is going to be equals to 1 minus the individual loop gains, which is this one. We have L1, L2, so the sum of these two, so it's going to be 1 minus into G2H1 plus there is this one negative, so we say minus G1, G2, G3, G4, H2. So this one is going to be equals to 1 plus, because the product of negative, you find the product of negative is going to give positive, so it's going to be G2 H1 plus G1, G2, G3, G4, H2. So lastly, we are supposed to come up with the transfer functions. That means we are going to substitute now based on our formula. So it's now going to be equals to, so our transfer function is going to be equals to B1 was this one, and multiplied by delta 1, which was 1, is going to be, we are going to retain that, which is going to be G1, G2, G3, G4, and then plus the forward part, the second forward part, which is this, multiplied by delta 2, and delta 2 is this one. So this multiplied by this, so it's going to be equals to 1 plus G2 H1 G5 G4, and then all over the overall delta, which is given by 1 plus G2 H1 plus G1 G2 G2 G3 G4 H2, and that will be the total or the overall transfer function of that signal flow graph. So, and that is those are the steps. That is the step on how to determine the overall overall transfer functions of a signal flow graph. We use this formula. So after that, we can say thank you. And in case if you have a question, then please write to me, and I will answer your questions. So if you still need more explanation for the discussions of the Mason formula, then please write a comment, and I will hesitate to chip in trying to help you. Most of these questions usually come in exams, so I want you to take them if you are doing college exams, doing control systems. So these are some of the questions that usually comes in an exams. So I'm here to help you, and if you have a problem, you don't, please write to me, and I will help you. I will guide you until you master this concept. So let's meet next time.